In this video, I will be explaining about real numbers. So, what are real numbers? Numbers in general can be classified into two types. One is real and the other one is imaginary. Take a number line for example. So this is a number line which consists of all the positive numbers and all the negative numbers. Any number that can be represented in this number line are called as real numbers. So let us take an example, minus 2. So minus 2 is right here. So that is a real number. Now what about 3 by 2? 3 by 2 will be 1.5. So it is somewhere between 1 and 2. In the middle of 1 and 2 will be 3 by 2. So we have represented 3 by 2 also in the number line. So that is also a real number. What about square root of 2? Square root of 2, the value will be 1.14128. What about this number? This number is present somewhere here. Just little bit in front of number 1 in the number line. But when we talk about a number like this number cannot be represented in the number line. So this is called as an imaginary number. Square root or cube root of any negative number is called an imaginary number. So in this video, we'll be talking about real numbers only. Real numbers are further classified into rational and irrational numbers. What are rational numbers? Rational numbers are numbers that can be represented by the form p divided by q, where p and q are integers. Both p and q belongs to, this is a symbol for belongs to integers, and also q is not equal to 0. What happens when q is equal to 0? Let us say for p let's take 5 and for q we will take 0. Then the answer will become infinity. So in order to avoid this, the condition is rational numbers is of the form p by q, where p and q belongs to integers and q is not equal to 0. Some examples of rational numbers are 3 by 2, minus 6 by 8, 13 by 17, etc. These are called rational numbers. When you write these rational numbers in decimal form, for example 3.3 divided by 2 can be written as 1.5. The decimal form is terminating. If it is non-terminating, like in the case of 13 by 17, then it will be non-terminating but recurring. Let's take a simpler example, 1 by 3. 1 by 3 is equal to 0.3333. It is a non-terminating decimal, but on the number 3 is recurring in this decimal, hence it is a rational number. But irrational numbers cannot be represented in this form p by q. The decimal form of irrational numbers will be non-terminating and also non-recurring. Some examples of irrational numbers are square root of 2, cube root of 3. Pi is an example of an irrational number or a number like this. A non-terminating decimal, which is also non-recurring, is an irrational number. So now let's talk about the non-terminating and terminating fractions. Let us consider a fraction p by q. What are the conditions for it to be terminating? A fraction p by q is terminating if q is of form 2 to the power m or 5 to the power n or 2 to the power m 5 to the power n. What this means is q should be having factors 2 and 5 only. So for example, let us take number 7 for p, and for q let us take 8, and let's try to find the decimal value of this. Dividing 7, so we'll add a decimal point and make it 70. 8 5s are 40, 8 6 are 48, 8 7s are 56, 8 8s are 64. Subtracting we get 6 0, 8 7s are 56, 4 0, 8 5s are 40. Now we got a remainder 0, and the decimal value of 7 divided by 8 is 0.875. In this case, the q which we have considered is 8, and 8 can be written as 2 into 2 into 2. So the factors of 8 consist only of 2. So the decimal was terminating. The same way, if we find out for 7 by 25, a decimal point, after that multiplying by 2 we get 50, remainder will be 20 and a 0. 25 8 times will be 200. So the decimal value of 7 by 25 is 0.28. This is terminating because 25 can be written in the form 5 into 5. The same is true for 7 by 50, which will give us a decimal value 0.14, and 50 is written in the form of 5 into 5 into 2. It has factors 5 and 2 alone. Okay, so when a fraction is of the form p by q and q's factors are 2, 5, or only 2 and 5, then the decimal will be terminating. Now what are the conditions for non-terminating decimal? Non-terminating decimal is also of the form p by q, but q has some other factor other than 2 and 5. If there is any other factor along with 2 and 5 or even without 2 and 5, then the decimal value will be terminating. We saw the example 1 divided by 3, which will give him 0.333, non-terminating but recurring. The same way we can choose this example 1 by 30. So 30 can be written as 2 into 5 into 3. So this is having 2 and 5, but along with that a 3 is also present. So what will be the result of this is 0.0333. So when and any other when the q value consists only of 2 and 5 multiples, then the decimal is terminating. If it has other factors along with 2 and 5, then it is non-terminating but recurring fraction. Now let us talk about prime numbers. Before talking about prime numbers, I've been saying a lot of using this word factors a lot. So what is factors? Any number, for example, we'll take 62. So any number, in this case 62, can be expressed in the term of its factors. Like 62 can be represented as 31 into 2. So 31 is a factor, 2 is another one factor. There are also other factors for 62, which is 1 and 62 itself. When you multiply 62 with 1, we get 62. So any number that can divide this number with the remainder 0 is called a factor for this number. So every number has factors. For example, 8 has factor 4, 2, 1 and 8. All these numbers can divide 8 with a remainder 0. Hence they are called factors. So now we were talking about prime numbers. What are prime numbers? Prime numbers has only two factors. Some examples of prime numbers are 2, 3, 13, 31. All these numbers can be represented only like this. They can be divided by themselves or they can be divided by 1. They have no other factors other than 1 and themselves. Such numbers are called prime numbers. Prime numbers has only two factors. What are composite numbers? Composite numbers has more than two factors. Example will be 4. 4 has factors 4, 2 and 1. It has 3 factors. 26 has factors 1, 26 and 13 and 2. So this is also a composite number. There is a special number which is neither prime and also nor composite. And this number is the number 1. Number 1 has only one factor, which is itself. Hence it is in a special category called neither prime nor composite. Now let us talk about a theory called fundamental theorem of arithmetic. The fundamental theorem of arithmetic states that any number can be written in form of its prime factors which is unique to the number irrespective of the order. So this fundamental theorem of arithmetic says every single number has a unique set of prime factors. So what are prime factors? We just saw what factors mean. Prime factors are only prime numbers, on the factors of any number consisting only of prime numbers. Prime factors are prime numbers which when multiplied will give us a number. So let us consider an example, 66. So 66 has factors 1, 66, 33, 2 and a lot of factors, but 66, 33 are not prime numbers. Prime factors of 66 are, we can find it out by dividing it. First we can divide it with 2, we will get 33, then by 3 we will get 11, then by 11 we will get 1. So 66 can be written as 2 into 3 into 11. These numbers are called the prime factors of 66. 66 is also divisible by 33, but since it is not a prime number, it is not a prime factor of 66. It is only a factor of 66. The prime factors of 66 are 2, 3 and 11. Now this fundamental theorem of arithmetic says that if we do not consider the orders in which the prime factors are written, then this set of numbers is unique to 66. 2 into 3 into 11 represent only 66 and no other number. That's what this theorem is stating. So if let's take the number 45. 45 can be divided by one student like this, dividing by 3, 1, 15, 15 by 3 is 5. Again by 3, we'll get remainder 5 and 5 divided by 5 is 1. But the same 45, a second student might divide it like this. 45 divided by 5 is 9, then 3 and another 3. So first student will write 45 is equal to 3 into 3 into 5. Second student will write 45 as 5 into 3 into 3. A third student might divide it like this, dividing by 3, 1 and 5. Now dividing by 5 and again by 3. So the third student will write it like 3 into 5 into 3. In all these cases, the prime factors are 3, 3 and 5, but the order in which the students written it are different. So this theory states that if we do not consider the order in which we have written, then the set of numbers is unique for 45. Any number can be written in form of its prime factors, which is unique to the number irrespective of the order. So now let we see about HCF and LCM of a number. HCF is highest common factors, common factor, and LCM is least common multiple. When we have been given with two numbers, let's take the numbers 52 and 70 as an example. The highest number that can divide both 52 and 70 with the remainder 0 is called the HCF of these two numbers. The highest number that can divide two numbers with the remainder 0 is called as the HCF of that number. There is also another name for HCF, which is GCD, greatest common divisor. The divisor which is greatest and common for both the numbers. So what is LCM now? Same two numbers 52 and 70. LCM is the smallest number that can be divided with both 52 and 70 with the remainder 0. So the smallest number that can be divided with these two numbers is LCM, and the highest number that can divide these two numbers will be HCF. So for finding HCF, we can use the long division method, in which we put the 70 as the dividend and 52 as the divisor, and we will divide it normally. 52 times 1 is 52, and the remainder will be 8, 18. Now since we have gotten a remainder, this remainder will become the divisor and 52 will become the dividend. Now if we try dividing 52 by 18, 18 times 2 is 36. We can use that and we will get 16 as a remainder. Now again we will divide this new remainder with the previous dividend, and we will get remainder of 2. Again using this as the dividend and this as the divisor, and we got a remainder 0. When we are getting 0, the divisor which we have last used will be the HCF. So in this case the HCF is equal to 2. This is how we find out HCF by using long division method. And for LCM, in lower classes you might have used the method by factorizing it commonly. So both the numbers are divisible by 2. 52 dividing by 2, 2 2s are 4, remainder 1. 12 by 2 is 6. 2 3s are 6, remainder 1. 10 by 2 is 5. Now the number that is commonly divisible for both of them, there is no such number. So let us divide them individually. 26 can be divided by 2, we'll get 13, and 35 will remain the same. Now dividing with 13 we'll get 1 and 35. 35 is divisible by 5, 1 comma 7, and 7 will give us 1. Now the product of all these numbers will be the LCM. 2 into 2 into 13 into 5 into 7. This will be 2 to 2 is 4 into 13 into 7 5s are 35. 13 times 4 is 52 into 35. 52, 35 multiply 5 2s are 10, 5 5s are 25 plus 1 26, 3 2s are 6, 5 3s are 15. 6 plus 6 is 12, 5 plus 2 7 plus 1 8, 1. So LCM is equal to 1820. So 2 is the common factor for both of them, highest common factor for both of them. 2 is the biggest number that can divide both 52 and 70 with the remainder 0. And 1820 is the smallest number that can be divided with 52 and 70 with the remainder 0. So the LCM and HCF that we found out just now is 1820 and 2. Correct? So we can see that 2 is a factor of 1820. That is 1820 can be divided with 2, and we will get a remainder 0. So 2 into 910 will give us 1820. So 2 is a factor of 1820, and this will be true for every pair of numbers. For every pair of numbers, the HCF will be a factor of LCM. Now let us see a different method for finding out HCF and LCM of two numbers. The method is prime factorization method. So we just learned how to write a number as its prime factors. So now we are going to use that method to find out HCF and LCM. So for this we will take example 39 and 58. So 39 can be if we factorize it, dividing by 3, we get 1 3 and 13. So 39 can be prime factorized into 3 into 13. Same way, now let us prime factorize 58, dividing by 2. 2 2s are 4 and 2 9s are 18. So 58 can be written as 2 into 29. So now we have found out the prime factors of both these numbers. Now we are going to find LCM and HCF from the prime factorization. And for LCM, what we need to do is we need to write all the factors, all the prime factors, and for each prime factor, the highest exponent value, the highest power of each term should be used. In this case, none of them are having exponents, so we don't have to worry about that. This will be the LCM of these two numbers. And for HCF, the common factors we need to take. In this case, there are no common factors, so we will just write 1, because 1 is always a multiple of everything. So 1 will be common. We can write 1 as the HCF. This is how we find out LCM and HCF using prime factorization method. Let us take another example, 64 and 1024. 64 prime factorizing, 10 by 2 is 8, 8 by 2 is 4, and 4 by 2 is 2. In the same way, we will prime factorize 1024 dividing by 2 by 12 dividing by 2, 256. 16 by 2 is 8, 8 by 2 is 4, and 4 by 2 is 2, and finally 2 by 2 is 1. 64 can be written as 2 to the power 1, 2, 3, 4, 5, 6. So 64 is 2 to the power 6. 1024 is 2 to the power 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the LCM is equal to, the prime factors are only 2 and the highest power of the prime factors is 10. So 10. The common factors between both of them is 2 and the lowest exponent is 6. So we have to write 6 in the HCF. This is how we find out LCM and HCF using prime factorization method. Let us see just one more example to be very clear about prime factorization method. So we'll choose numbers 135 and 225. 135, if we prime factorize, we can divide it by 3. 3 4s are 12, remainder 1. 3 5s are 15, again by 3. 3 1 is 3, remainder 1. 15 by 3 is 5, a third time by 3, remainder 5. And 225 dividing by 3. 3 7s are 21, remainder 1, dividing by 5, again by 3. 3 2s are 6, remainder 1. 15 by 3 is 5. Now dividing by 5, get 5, again by 5 we get 1. So 135 after prime factorization will become 3 to the power 1 2 3 into 5, and 225 after prime factorization will become 3 square into 5 square. For LCM we need to write all the prime factors. Here prime factors are 3 and 5, and we need to use the highest of the powers. So in case of 3 the highest power is 3, and in case of 5 the highest power is 2. So the LCM will be 3 to the power 3, which is 27, into 5 square is 25. 27 times 25 is 7 5s are 35, 5 2s are 10 plus 3 13, 7 2s are 14, 2 2s are 4 plus 1 5. The LCM of these two numbers is 675. Now for HCF, the common factors are 3 and 5. Both the numbers are common for both of them. And after we write down the common factors, we need to choose the power which is highest and common for both of them. So 5, for 5 the highest common factor is 1, and for 3 the smallest factor is 2. So this will be written as 9 times 5 of 45. The HCF of both of these numbers is 45, and the LCM is 675. So this is how we find out HCF and LCM using prime factorization method. Just a small recap of everything that we have seen in this video. The numbers can be categorized into real numbers and imaginary numbers. Real numbers are the numbers that can be represented in a number line. They include rational numbers, irrational numbers, integers, whole numbers, natural numbers, and everything. Imaginary numbers cannot be represented in a number line because they are of the form negative square root of -1, which cannot be represented in a number line. This is an imaginary number. So real numbers are categorized into rational numbers and irrational numbers. Rational numbers, when we express them in decimal term, it will be terminating decimal, otherwise it will be non-terminating but a recurring decimal. Irrational numbers, in the decimal form, it will be non-terminating and non-recurring. Rational numbers can be expressed in the form p divided by q, where both p and q are integers and q is not equal to 0. Now the conditions for a fraction to be terminating. So a fraction is represented as p divided by q, and if q has prime factors only 2 or only 5 or both 2 and 5, then the fraction is terminating. The factors of q should only be 2, 5. If there is any other factor present like 3 or 7, then the fraction will become a non-terminating fraction, but it will be recurring. Now then we see what is the meaning of factors. So any number that can divide a number with the remainder 0 is called as a factor of that number, and prime numbers has only two factors, the number itself and 1. composite numbers has more than 2 factors, and one is neither prime nor composite number because it has only one factor. Then we saw the fundamental theorem of arithmetic, that is, any number can be written in form of its prime factors, which is unique to the number irrespective of the order. So any number, in this case 45, can be written only as prime factors, and those prime factors will be unique to 45. That is the theory. Then we saw how to use this prime factorization and find out HCF and LCM. First we saw the traditional method that we already used in lower classes, which is the long division method for HCF, where we divide the number with the other number, then the remainder will become the dividend, and the first divisor will become the dividend, and the remainder will become the divisor. Then if we keep on repeating that process, the last divisor which we used to get a remainder 0 will be the HCF of the both numbers. And for LCM we will use, first we will factorize with common numbers, then we will factorize them individually, and the product of all the factors will be LCM. But LCM and HCF can also be found out using prime factorization method, where you write the numbers as their prime factors. Then the LCM will be, for finding out the LCM, you need to write down all the prime factors which are present, and you need to add the powers which are the greatest for each of the prime factors. And for HCF, you need to write down only the factors which are common in both of them. In this example, for LCM, the prime factors are only 2 and the highest exponent is 10, so we written 10. And for HCF, 2 power 6 is common, 2 power 6 is common here also, so the highest of the common we have written here. Here also we have 3 cube into 5 and 3 square into 5 square. The common factors are 3 and 5, and the power highest power for 3 is 3 and highest power for 5 is 2, so LCM is 3 cube into 5 square. HCF, the common factors are 3 and 5, we written them down. Then the smallest of the power for 3 is 2 and the smallest of the power for 5 is 1, we have written them down, and we found out the LCM and HCF of the numbers. So far, if you have any doubts in this chapter, you can discuss in the comment section.